Hello everyone. Good morning, good afternoon, and good evening, wherever you are. Myself are Sony, and I will be moderating the session. So, dear authors and invited guests, welcome to Technical Session 5D. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 8th World Conference on Smart Trends in Systems, Security, and Sustainability, WS4 2024, London, UK. The eighth edition of this conference is being organized in a hybrid mode. The physical event was organized on 23rd of July in London, UK, and the virtual event is being held through Zoom from 24th to 26th July 2024. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for the question and answers. On 10 minutes, I will raise a gentle reminder. There's another request to all the participants that you may please stay connected with us till the closing remarks so we can capture the good memories of this virtual conference. Further, if you have any query or update, then you can write it to me in the chat box. So just before we get started, I'd like to invite our session chairs to chair the session. So first we have Dr. Gitanjali Shinde. Dr. Gitanjali Shinde has overall 15 years of teaching experience. She is presently working as assistant professor in Department of Computer Engineering at Vishwakarma Institute of Information and Technology, Pune, India. She has presented a research article in World Wireless Research Forum, WWRF, meeting in Beijing, China. She has published 50 plus papers in national and international conferences and journals. So we have another session chair of this session is Dr. Vijayta Kumawat. Dr. Vijayta Kumawat is a deputy HOD and associate professor in Department of CSE at Jaipur Engineering College and Research Center. She has 17 plus years of teaching experience. Her expertise is in ad hoc networks, wireless sensor networks, and Internet of Things. She has 45 plus international and national publications. So I welcome you, so both of the chairs.
Thank you,
Ma'am, if you
Harsh,
have
for a
any query.
nice introduction. Thank you, everyone.
Thank you, ma'am.
Thank you, sir. Thank you for this introduction.
So moving forward for our first presenter, we have George Lewis, and he's going to present the paper on artificial neural networks for speaker verification. Dear presenter, you may please start your presentation.
Yeah, thank you very much. All right, can you see my screen?
Yes, we can.
Okay, thank you. Yeah, I'm Jose Luis Medellin Garibay, and I will present artificial neural networks for speaker verification. One second. Okay, yeah. Our main motivation of this is biometric recognition systems such as fingerprints, voice, and face are specific to individuals. The advantage of that is that cannot be forgotten. That's a good one, and cannot be easily stolen. This also it's part of security on the servers where you are saving it, but should not be easy to steal. And it's easy to acquire. And for this case, it's just save your voice. There is a great opportunity implementing this because the smart devices technology is increasing significantly. In 2020, we have 294 million of smartphones, and 37% of the houses has a smart device. And those smart devices can be used by voice, and they need a better authentication and security because they are connecting to internet. They can control smart devices or another small, smart devices. So this is important to have a good security related to all the devices that you can control in your house or general other places like logins to your bank account, to your email. So this can be like a good way to secure your data. And for the speech processing, we have different application. The most common one is the speech recognition. Also, we have language identification and speaker recognition. Now, talking about speaker recognition, we can have two different ways. One is text dependent or text independent. So the text dependent, it's someone is always saying the same phrase. And in the text independent, it can be just a talk or any word on any phrase, and she'll be able to detect the speaker. In this speaker recognition, we have different tasks. Speaker identification, speaker detection, speaker derization, and speaker verification, which is the one that we are working on this paper. I will tell you a little bit more about the difference between speaker identification and speaker verification, because it can be, you can see it sometimes as the same, but they are not the same. So the speaker identification, it's determine who is speaking from a no group of speakers. And the speaker verification is just to verify if the speaker is the one that it's claiming to be that person. So we save the input voice with a single store voice template. Like you can say a password or any phrase, and we can determine if it's the speaker or not. Going a little bit back on the other task, the speaker detection is when it's talking, and the speaker derization, it's like in this meeting, determine who is speaking at which point and the length of that speaking. So in this speaker verification, one of the benchmarks is ruled by the Linguistic Data Consortium and by the National Institute of Standards and Technology. So they created kind of challenge, which is called the Speaker Recognition Evaluation, where they create a data set with multiple telephone calls, and they're like saving all those calls, and they know the language, the speaker identity, other features like if it's a male, female, and if it's one person or two, that kind of features that they are having. And it's really good because one of the other data sets, it's Voxelev. That one, it's really popular right now. But the big difference between this speaker recognition evaluation and Voxelev is Voxelev, the audio or the speakers are like super clear voice. They are mostly actors in television saying some phrases, and you can train with that. But those are not like real world scenarios. In the telephone calls, it's more real world because you have noise, you have some spaces between the talks. So it's more like a real world scenario. One of the key things to get the speaker verification is the voice feature extraction. So the one that it's more used, it's the male frequency space cepstral coefficients, MFCCs. So those ones capture the power spectrum of the voice, and it's basically to get the real characteristic of the voice. And it's more like how humans listen that, and we send that to the computer, and the computer can determine easier if it's a user or not. There are other feature extractions, but the most popular is the MFCCs. And I will not go deep on the steps, but if you see in the image on the right, we have the raw audio, and then we take the features and we get just the data that we need. Also, we reduce the noise, and it's easier to start training with that. So we used two different models in order to do this speaker verification. One is the probabilistic neural networks. They are inspired by Bayesian networks and use kernel-based functions. And yeah, the architecture, it's, let's say, like a regular deep neural network. The input are the MFCCs, and then we apply the parent unit, which is the second layer. And there we apply the Gaussian function with the basis function, which is defined at the bottom of the image. And then we have the summarization layer. And then at the end, we have the output. And in this case, we're doing classification. So each output, it will be a speaker, and it will say which one. If it's 0, it's not the speaker, and the output with 1, it will be the speaker. The other model that we tried, it's emphasize channel attention, propagation, and aggregation in time delay neural networks, or ICAPA-TDNN. This model, it's one of the best models that we found that are using right now. They are based on something called X vectors. X vectors is also one of the best models, but this one, it's the next step for X vectors. So it can work better in order to get if the user is the one that it's claiming to be that user. We have the architecture of the model. It has a channel attention mechanism. Then it has the information propagation and the aggregation methods. So the data set and the methodology that we used, as I mentioned a little bit before, we used the NIST SRE 2008 dataset. So the full dataset, it's 1,270 speakers and like almost 99,000 test segments. So for this particular case, we tested with 9 speakers and 111 test segments. All of them are men. All of them are phone calls. All of them are in English, and all of them also are speaker native of the English language. In order to get the results in biometrics, it's not really common to use the accuracy. We use equal error rate, which first we need to calculate the false acceptance rate, which is the rate when you say that in imposter it's actually the real user, and also the false rejection rate, which is the opposite. A real user is incorrectly rejected. So we find the cross in those rates, and that will be the equal error rate. The lower the equal error rate is, it's the best accuracy. Well, yeah, accuracy, or if it's working or not. So for the results for the probabilistic neural networks, the equal error rate result average, it's around 30%. If you see in the table, we got a lot of perfect rates, and also we put the accuracy to have it also a little bit better explained. So it's having a really good performance. And for the E-kappa TDNN model, the equal rate average is around 41%. If we compare, we got only one at 0%. The others are not really good. It's mostly like 50% on the equal error rate, and the accuracy, it's kind of the same. So not that big difference. Based on that, the conclusions that we can get, it's the PNN is the best performance with small data sets. Why? Because E-kappa TDNN, I think, is more for bigger data sets. So for the future work that we have planned, it's use the full data set, so we can train and test all the users for E-kappa TDNN and see if it's improving or not. Also, we can mix both models and see if we can improve it. And yeah, for the PNN, in order to use the full data set, maybe we will need to use parallel computing to make it faster. And yeah, not take a lot of time training and testing the models. And yeah, that's pretty much it. Do you have any
Very
questions?
nice presentation. Very nice presentation. You have present your work very nicely. Congratulations. And I have some questions related to future work, but you have mentioned in your last slide. So no question from my side. Very good, very nice.
Hello. Am I audible?
Hello? Yep.
Yeah. It was nice presentation. I just like to know that how you handle noise in the data.
Yeah, that's part of the pre-processing that we did. I didn't put that because of the time, but yeah, first in the data pre-processing, we first tried to reduce the noise using different techniques, and also they provide like two channels. One channel it's one user, and the other channel it's another user, because they are in a call. So we have this challenge to split, having just one user to train, but sometimes we have a lot of noise, and also the two users in the same channel. So we first started deleting all the noise, also the other user that is not the one that we are trying to train or test. And then after all that, we send that to the feature extraction. But yeah, one of the big challenges as well, it's delete all the noise that is in the background.
Okay. Thank you. That's it from my
Thank-
side.
Yeah, thank you.
Okay. If anyone has any question to the author.
Yeah, thank you very much.
Okay. So moving forward for our next presenter, we have Mijon, and is going to presenting on econometric analysis of the impact of Takaful Financial Services on economic development, case study of Malaysia. Dear presenter, do we have you over here? So it's not available. So moving forward for next presenter, the next presenter we have is Zokip, and he's going to presenting on economic forecasting in higher education, ARIMA model application for financial planning at Tashkent State University of Economics. Do we have anyone from this paper? Okay, so moving for next presenter, Nigora Primova, and she's going to presenting on evaluating the economic factors affecting state share reduction in commercial banks of Uzbekistan. Do we have any author from this paper who presenting? Not an issue. Moving forward.
You are mute. Please unmute.
Hello, am I audible now?
Yes, you are now.
Okay. So just gonna announce once again from this paper, like, do we have any author from this paper? Like the paper title is Econometric Analysis of the Impact of Takaful Financial Services on Economic Development, a case study of Malaysia. Anyone from this paper? Okay, so moving for next. Zokir Mamadiro, and it's going to presenting on economic forecasting in higher education, ARIMA, model application for financial planning at Tashkent State University of Economics. Do we have any author from this paper title? Okay, so moving forward next. Nigora Primova, and she's going to presenting on evaluating the economic factors affecting state shares reduction in commercial banks of Uzbekistan.
Yes, good morning.
Good morning, ma'am. Yes, ma'am, you can present your paper.
Yes, now it is visible.
Them evaluating the economic factors affecting state share reduction in commercial banks of Uzbekistan. After this, and abstract the role of state ownership in commercial banks has significant implication for economic stability and efficiency. Utilizing data from the Central Bank of Uzbekistan from January 2018 to October 2023, we applied after regressive distributed model and structural equation modeling to analyze the relationships between state ownership in commercial banks and various economic factors, including the inflation rate, average weighted interest rates on loans, and short-term deposit interest rates. Similarly, 1% increase in the average weighted interest rate on loans results in a 2 or 4% decrease in the capital of these banks. Conversely, a 1% increase in the short-term deposit interest rate causes causes 2% increase in the capital of state-owned commercial banks. Introduction. The objective of this study is to investigate the key economic factors affecting the reduction of state shares in commercial banks in Uzbekistan. By employing econometric models such as ARDL model and SEM, this research aims to provide a comprehensive analysis of how variables like inflation, average registered interest rates on loans, and short-term deposit interest rates impact the capital of state-owned commercial banks. Methodology, data. This study employs a combination ARDL modeling and SEM to analyze the factors influencing the reduction of state shares in commercial banks in Uzbekistan. The analysis uses data from the Central Bank of Uzbekistan, spanning from January 2018 to October 2023. And this data for this study includes 70 monthly economic indicators from the Central Bank of Uzbekistan. Hypothesis. This study tests the following hypotheses. Null hypothesis. There is significant correlation among the capital of top commercial banks in the country, the inflation rate in the national economy, and average lending rate, and the average deposit rate for short-term deposits in commercial banks. And second alternative hypothesis, there is no significant correlation among the capital of top commercial banks in the country, the inflation rate in the national economy, the average lending rate, and short-term deposits in commercial banks. This study suggests that other factors not considered in this research might play a significant role in influencing the decrease in the capital of top commercial banks in the country. Statistical tests. First, to ensure the robustness of the models, several diagnostic tests are conducted, including Durbin-Watson test, Shepard-Welk test, Bruch-Pagan test, and variance inflation factor test. Results. The analytical graphic matrix of dependent and independent variables was structured as follows. Figure 1, scatter plot between dependent and independent variables. First table, correlation matrix of dependent and independent variables. In the above one graphics, they depicted that data illustrates strong correlations indicating unique position and outcomes. The density of data points in the visual representation indicates clustered placement of points and their inclination towards centralized distribution along the axis. In table 1, the results indicate a clear, strong, and sometimes inverse correlation between the independent variable and its influencing factors. The correlation matrix in Table 1 demonstrates the absence of multicollinearity between the dependent and independent variables. Conclusion, this study finds that 1% increase in the inflation rate leads to 0.28% decrease in the capital of state-owned commercial banks. This negative relationship indicates that higher inflation values and increases operational costs. Short-term deposit interest rates, 1% increase in short-term deposit interest rates causes 2.52% increase in the capital of state-owned commercial banks. This study highlights the scientific impact of inflation, loan interest rates, and deposit interest rates on the capital of state-owned commercial banks in Uzbekistan. The findings provide valuable insights for policymakers to develop strategies that balance state intervention with market efficiency, ultimately aiming for a robust and resilient banking sector. By understanding these economic factors, Uzbekistan can achieve a more competitive and dynamic financial environment, contributing and overall economic growth and stability of the country. Thank you for your attention.
It was a nice presentation. Can you elaborate more on data set, like how many records you have taken and from how many branches or bank you have taken data? And second question is that can you elaborate more about statistical test results from each state test? What you have found, your findings?
First answer is findings will offer insights for policymakers and devise strategies that balance and forced intervention, market efficiency, ultimately aiming to achieve banking sector.
Okay.
Results is analytical graphic metrics, data, and hypotheses.
Okay, nice presentation. Thank you.
Thank you.
Vijeta ma'am, do we have any question for us?
No question, sir.
Okay. So next presenter we have Juan Carlos Briones Marcias, and he's going to presenting on public space based on ISO 14001-2015 environmental management for higher education centers. Dear presenter, you may please start your presentation.
I am not the presenter. No, I was in the paper with Jose Luis, where I am the co-author with the Jose Luis presentation who already presented.
Okay. So we'll wait for next 2 minutes if any other presenter will join us till then. Hello, dear authors. As we have completed the presentations and some of the presenters are absent over here, So we'll continue. We'll conclude this session. So now I would like to thank all participants for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. On behalf of the whole team, thank you for your support during this 8th version of this conference and the previous 7 version of this conference. We will be happy to have you all in the next year, 2025, in the 9th version of this conference. Further, all the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months, so kindly cooperate with the team WS4 2024. At the end, I also thank our session chair for chairing the session. And there is one token of appreciation to be the chair on behalf of Global Knowledge Research Foundation and WS4 2024. Dr. Gitanjali, this is for you from the Global Knowledge Research Foundation and WS4 team.
Thank you, Harsh. Thank you for giving.
Okay.
Okay. Thank you.
And ma'am, do we have any remarks for presenters?
It was the nice presentation. All the best for their future work.
Okay, thank you, ma'am. So moving for next, we have Vijeta, ma'am. And ma'am, this is for you to be the chair on behalf of Global Knowledge Research Foundation and WS4 team.
Thank you, Harsh. Thank you so much.
Okay, so now at the end, I would like to request you all to turn on your camera so we can capture the good memories of this virtual conference. Okay, thank you all. Thank you for your presence over here. Thank you.
Thank you.